Hello and welcome back to another electricity and magnetism extra practice video. Today we will be discussing the electric field. As always, all information and questions are from the Essential Calculus-Based Physics Study Guide Workbook, Volume 2 by Chris McMullen. So to start, we will be discussing the electric field. The electric field can be described as the area around a point-like charge to where the electric force is applied. It can be found using this equation to find this equation where the electric force is equal to the product of the charge and the electric field, or the electric field is equal to the product of Coulomb's constant times the absolute value of a charge divided by the distance from the charge squared. Say you have a point-like charge here that has its own electric field, and you have a charge here within the field. Some other important information to remember is that K is the constant of proportionality, or Coulomb's constant, and is equal to 8.99 times 10 to the 9th. For simplicity's sake, I will be using 9 times 10 to the 9th. Your elementary charge of a proton or electron is equal to 1.6 times 10 to the negative 19th coulombs. Like charges repel and opposite charges attract, and the distance formula is very useful to know between the point charge and the charge you're looking for. And that distance is going to be the square root of the difference between the x's squared added to the difference between the y squared. For our first question, a small fur ball from a monkey has a net charge of negative 300 microcoulombs. The fur ball is in the presence of an external electric field with a magnitude of 80,000 newtons over coulombs. What is the magnitude of the electric force exerted on the fur ball? All right. In order to find this, we first have to use one of our given equations. F E is equal to Q times the electric field. We are given our charge, and we are given our electric field. They're here and here. So then we will have negative 300 times 10 to the negative 6 coulombs, because micro is 10 to the negative 6. And then we multiply this by 8 times 10 to the 4th newtons over coulombs. All right, since we're multiplying these, we know that our tens, we are going to add our 10, or add the exponents for our tens, so we will end up with 10 to the negative 2, or to the negative 2. We know that we have coulombs in our numerator and the denominator, so these are going to cancel, and our units are going to be left in newtons. Now we have to multiply 8 by 300, negative 300. This will result in us getting 2,000. This will result in us getting 2,000, or negative 2,400 times 10 to the negative 2. If we were to simplify this, we would just end up with negative 24 newtons. But because the question is asking for what is the magnitude of the electric force, we will be taking the absolute value. And so our resulting answer is 24 newtons. For our next equation, a gorilla's earring has a net charge of 800 microcoulombs. Find the magnitude of the electric field a distance 2 meters from the earring. For this equation, we will be using, or for this question, we will be using the equation E is equal to K times the absolute value of the charge Q divided by distance r squared. We are given our charge here, so we will be using the absolute value of 800 microcoulombs, or 800 times 10 to the negative 6 coulombs. Then we are going to multiply this charge by Coulomb's constant, which in this case will be 9 times 10 to the 9th newtons times meters squared over Coulomb squared. Then we will divide this by 2.0 meters squared, which then becomes 4.0 meters squared. If we look at our units first, we see we have meters in the numerator, meters in the denominator, and so those will cancel. We have Coulomb here, we have Coulomb squared here, so we cross out coulombs here and the squared here, and we have coulombs in the denominator, leaving us with the unit newtons over coulombs, which is the unit for the electric field. Now we'll look at our tens. Because we're multiplying these tens by the same base, we'll add them together, which will get us 10 to the third. And because there's no tens down here, we don't have to worry. So we end up with 10 to the third. Now for evaluating our magnitudes, we have 800 here, 4 down here. We can change this to 2 divided by 1. And that effectively clears our denominator. And then we can multiply the 200 by 9 to get 1800. We could leave it like this, or we could simplify it by moving the decimal point 3 spaces to get 1.8 times 10 to the 6 newtons over coulombs, or we could leave it as 18 times 10 to the 5th. And again, thank you for watching this video.